Hi everyone. Today we're back to you. Today is April 17, and we will finish the electric field concepts. In the previous videos, I discussed and explained the electric field for insulators. Then after that, I explained the electric field for unit charges. Today we'll find the electric field and discuss the electric field and the electric potential, which is the voltage for conductors. For conductors. Now, the conductors is metallic spheres. Our objective today is to find the electric field, electric potential, which is the voltage for conductors. And I'm gonna at the end explain for you what the difference between the electric field and the electric potential between conductors and insulators. Insulator is done before, I explained it before. Now, if you have any question, just call us at this phone, send us a text message, or send me an email here. And if you have any question, I will be more than happy to explain and solve it for you. Let us start. To save your time, I done some of the job. This is what we have to do. Conductors, electric field, and electric potential for spheres. I draw the spheres. I have too many spheres here. Look it. Well, wow, Allah. Okay, I'm gonna explain why I have all these spheres. Okay. First, we're gonna start with the electric field. With the electric field. With the electric field for these spheres. Okay. Let us start with our class. I'm going to try my best to make it easy as much as can, I promise. I know some of the kids, they hate physics, but even if you hate something, you have, as I said before, please practice it. Please practice it. Okay. Then the first thing we're going to start is the electric field. The electric field. Let me just move this guy here. Okay, I'm going to start with the electric field. What's the difference between conductors and insulator in terms of the charge distribution? In insulators, if you remember, we said the charge distributed everywhere in the sphere. Plus, I'm going to make believe this one insulator, then you will find the charge all over the sphere. But for conductors, there's nothing here, nothing here, nothing here, nothing here. Where the charge will be, the charge will go to the surface of the conductor, which is here, 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 here. Okay. Then there is no charge inside the conductor. Good. This is the first thing you have to know. Now my objective is to find the electric field at point A, which is here, point B, point C. Point B here. Okay, let me just make a point C. Okay, A here, point A just here, in the center of the sphere, and point B and C here, and point C here, inside the sphere, but not on the surface. Then I have two cases, right? The first two cases. Watch what we're gonna do. Electric field at the center of the sphere, center, equal to 0. Wow, that's easy, simple. Electric field electric field at any point inside the sphere, E at B equal E at C equal 0. Then the rule saying electric field inside equal to 0 up to the surface, not in the surface, not on the surface, not on the surface, up to the surface, on the surface. Okay, good. Okay, then all from here to here, from here to here, from here to here, 0. From here to here, 0. Not okay. Now let us move the board and go to this, and let us see what's happened to the electric field when it comes at this point on the surface. Now, I advise you to go back and to see how we calculate the electric field, for a point charges. Electric field for point what? Electric field for point charges. Why point charges? Because we consider there is a charge, a point charge. We consider the whole sphere charge on the sphere as a point charge on the center, as point charge in the center. Good. That makes the things easy. And make our calculation easy. Then we consider like this. Let me move the graph. We're going to use this later on. Okay. I'll move all this guy. Down. Okay, we're gonna use it later on. Okay. I'm trying to make it organized for you guys as much we can. Okay. Then let us, like this, it's going to be like this exactly. Watch, we're going to have like this, the center, and this is the radius, which is, I'm gonna make it the same color as red. Okay, then we're gonna make believe the whole sphere as a point charge located at the center of the sphere, which is here O, and the charge is Q, and this my radius was R, and we calculate the K Q over D squared. D in this case from here to here is K Q over R squared. Done. That's all what you need to know. K is 9 times 10 to the 9 in Newton meter square over column. This is the unit of the K. Sometimes they ask about that. What happened then here? Then we calculate here, we have ABC. Let us use this point, the sphere, as point 1. Now let us move a little bit more from the sphere. Let us go to point 2. Now the distance will be, you see this distance from here to here. I'm going to take the distance from the point O to here. Remember, from the center to here. Then I'm going to have a one line. This line start from here to here, to the point 2, to the point what? 2. And my distance here is D. D and R, where D equals the distance from this surface plus R. Then, and we have a point charge at here Q, then E equal, go back to the class I told you, over D squared. And remember to find D, what you have to do? What you notice? When the denominator increasing, this amount what decreases. That means E1, I'm going to put here E2 less than E1. Good. E2, because the distance D is bigger than the radius R in here. Right? Okay. What happened here? We're gonna go further a little bit. A little bit further. This point 3. And this my O. This is my R, and this my distance D from here to here, my distance D. Then everything from here to here is my big D. My big D equal R plus D. And this, in this case, the distance D is bigger than this distance. Yeah, if you want, I'm gonna make this D1, D1, and this D2, and this what? D2. Okay. E equal K, Q. Q is located at the center, because as I said, remember, for conductors, outside from the surface and outside, we consider the charge to be a point charge located on the center, and the center. That's what I did. Over what? D2 squared. In this case, we have E2 less than E1, which is there, and here E3 less than this E3 less than E2. Wow. E1. Then the electric field decreases. Electric field decreases as a rational function, which is 1 over, let me just make 1 over d squared. Why? Because k black k and q both constant, both are constants. Okay, and the graph of this one, the graph is like that. Go fast. Okay, then let us graph the relationship which is here between these guys. I'm gonna bring the graph here with the graph. Okay, I'm gonna explain this now. I'm gonna put this guy here. Okay, now we said this my sphere. This my sphere. This is distance in meter, and this is the electric field, and if you want, Newton per column. Newton per column. We said the electric field from the center, 0, 0, 0, 0, 0, 0. Suddenly come to this point, which is on the surface, you see that? And has a value. The value here, we just solve it for you, which is k q over r squared at this point. Then after that, the electric field decreases, go exponentially, which is what I told you, 1 over what? D squared. We have a constant, time what? What my constant here? Depend on k and q. Okay. This is for conductors. Let us remind you with the insulators. You remember the insulator, the one I did? This is for insulators. Just to compare, if the radius is here, for insulators, if you remember, the line goes up, increasing, this for insulator. The electric field increasing to reach the maximum at the radius. Here are okay. Here the radius r. This point, at this point. Well, here the radius r. This for insulator and this conductors. And this insulator. Then this guy increasing up. Then after that, it start to be like conductors. You see, this for insulator increasing. Good. This is what we have quickly. I'm going to repeat this again. Here the electric field. the charge distributed on the surface of the conductors that cause the electric field from the point O to the surface equals 0. B, C inside. Then after that, on the surface, electric field for point charge. We consider all the sphere to be a point charge located in the center here. Then to calculate the electric field at this point, here we can apply the electric field formula, E equal KQ over D square, electric field for, and D in this case is my R. This is my electric field on the surface. Now when you start to go away from the surface at point 2, you have to measure the distance from the center to the point, which is D from the surface and R from the surface to the center. Then you add these values, we call it big D, D over R. Now this is KQ over D squared. A little bit further, that distance increasing, then we call D2. And I told you, when the denominator increasing, with this guy increasing, this value decreases. This value, when this increases, this decreases. That cause the E2 is less than the E1. Which one E1? E1 in the surface, which is here. E1 here in the surface. Why this greater? Because the distance here is less, and the distance here is bigger. Then after that, I went and I grabbed it. This is my sphere. From here to here, there is no electric field. At this point, the surface, the electric field jump to be what? KQ over what? R square. After that, the electric field decreases depending on 1 over D square. And we know from math, 1 over D square is a rational function, goes this way. And for advanced physics, this goes what? To 0 at infinity. When D goes to infinity, the electric field approaches to infinity. Here I just refresh your memory with the insulator. In a conductor, there is no electric field. Insulator starts from the 0 at the center, then goes up, increasing to the surface, then after that decreases. Good. What I have down there, I have potential. And this is what we're going to do next class. And I will solve example. Next class, I will explain for you how you find the electric potential for D3 sphere. I will put some point here and there, and I will finish this class next time. Have a good day, and remember to contact us at this either phone number or email. And this is the first part. I will give you the first part. I want you to study, to review, because next time I'm going to explain the electric potential. Then I will solve more problem. Thank you guys, and have a nice evening. Enjoy.